Welcome back to this recommender system series of videos. And, we want to start simple and with the basics. So in terms of the basics, non-personalized recommender systems and specifically popularity is sort of the, really, really strong baseline, kind of by definition. If they're popular, the likeliness of a new user enrolling in the system is kind of, the probability of them liking it is high. So it's a very strong baseline, and we will try to implement it in this video, and I'll show a different kind of variations of it. Let's go with what we're going to do here. So with MovieLens dataset, it's kind of a very famous and popular dataset to play around with, and it's with movies, and users have given ratings to movies. So in this case, we're just going to take this one, the latest small version, right? We don't need to play around with these things like on a huge data set, right? We just want to learn the fundamental concepts. So let's start with downloading this data set. So, you can go to this one. I'll link it, GroupLens, dataset MovieLens. And so what we'll do is we'll do vget. We'll get that one, and then we'll unzip it. We'll remove the zip file, and then we can move it to MovieLens small, let's call it. Maybe a little bit quick there, but so, this is just sort of to get the data. You can easily do this manually as well, right? So then what we'll do is if not ospath.exists of MovieLens small. If that's not the case, then we'll run this. So we now run that. We're downloading it. We're moving it to MovieLens small. So now if we check in this this folder, right, we'll have the important ones here are the movies and the ratings. That's all we're gonna play around with, really. So for that, we'll need pandas. So import pandas as PD. Let's also put this at the top. And then let's just load the one. So ratings data frame pd.read csv of MovieLens small ratings. And let's do the same for the movies. So there we go. And let's start with just taking a look at it, see how it looks like. So the ratings, we have a movie ID, a user ID, and a given rating. And then we also have a timestamp. All that we're interested in here is the user ID, movie ID, and the rating. So that's pretty much it. And then movies, data frame. Let's look at that one as well. So pretty basic, same thing. We have a movie ID here, similar like from the ratings, we have user ID, movie ID. With the movies, we have the movie ID and the title of that one, and also the genres. So what we're wanting to do is we want to use popularity. So how can we do popularity in this scenario? Let's say we have a new user that onboards the system, then we want to do better than random, right? And the strongest we can do there is popularity. Unless we go into more personalized ones where we actually have some user information and so on. But we're going to get up into that in future videos. These are still sort of non-personalized ones. So the first thing that we want to do here, let's maybe create a function for this. So define load data like this. And then let's just load that one. So we'll do it this way instead, and we've already seen this. All right, cool. So what we can do is, let's say we want to use the number of votes, just how many people have voted or have rated that movie, right? So maybe we can do, so maybe we could first start with number of ratings. We could do on this ratings data frame, we could group by the movie ID, right? And then we could take out the rating, and then we could do a count. So this is like pandas, data frame manipulation and stuff. I don't want to really get into that now, but so we're grouping by the movie ID, we're taking out the rating, and then we're doing a count. Just how many rating does that movie ID have? So basically, like how many rows do we have for that movie ID? And so if we just do a num ratings dot head of 5, we'll see, okay, so we have movie ID 1 has 215 votes, movie ID 2 has 110 votes. So from this, we could do, well, just give the ones that are the most sort of popular, right? So that is something we could do. Another thing we could do is use the hires mean rating. So yeah, if we would do this, if we do num ratings dot sort values, do it this way, then we'll get, all right, these are the movie IDs that we want to recommend. So we created a recommender system in like 2 lines, right? Pretty much. And actually it's gonna probably work pretty well for new users, but we can do better. So what we can do, for example, is we could use the mean rating. So if we do pretty much the same thing, but we instead change it to mean rating, and we do the same thing, and then at the end we do a mean. So let's look at this in a little bit more detail. So we could do movies data frame of num ratings. We could set that to be the movies data frame movie ID, and then map it on the number of ratings. Similarly, we could do movies data frame of mean rating, and we map it on the mean rating. So basically we take out the movie ID and then we map it to what the value is for the num ratings we just did. So now we could look at it like this, and we could sort values, and then we could do a by num ratings, for example. Now this way we'll actually get like the names of them, which is nice. So we can see here the num ratings, the one that's at the top: Forrest Gump, Shawshank Redemption, Pulp Fiction, Silence of the Lamb, The Matrix. All of these are really good movies, right? Or depending on your taste, but like these are known, very highly rated movies. The num ratings don't really, there's a high correlation between the num ratings and the average rating, but they're not necessarily, they don't necessarily have to be. So let's say that we instead do the same thing, but with the mean rating. That should potentially be better. And then we run into a little bit of a problem where the issue here is that we only have one rating. So we need to solve that by, let's say we could circumvent the problem by requiring that we have a certain number of ratings before we consider it. Otherwise, we'll recommend these movies, which I don't know, I've never heard about. So, but that's not a sort of a general solution, right? You need to kind of tinker with that, and how do you choose the cutoff threshold and so on. But generally there's a damped mean formula we can use instead that takes into account both the num ratings and the average rating that we have for that movie. So all right, so what I've done here is I've copy pasted in the formula for the damped mean. So here it's just a simple formula, really. We'll walk through it to understand how it works. But so we have S of I, which is the damped mean rating for an item I. So let's say item ID or movie ID 1, for example. So what we do here is that if we first just ignore the plus signs here, let's say that A here equals 0, so we just cross this thing out. Then we have the sum of all the ratings for that particular movie item I. So we'll sum all the ratings we got for Shawshank Redemption, and then we'll divide by a capital UI, which is the total number of ratings. So this is just a mean, right? It's just a mean of what we got for Shawshank Redemption. And so if we set A to 0, it will just be the mean, similar as we have above, right? But if we set A, let's say if we were to ignore the left side and we only have this side, then what would happen is that we would be able to cross out the A's and we would only have mu, which is the global mean rating across all items. So if we set A to a really, really large number, we'll go towards the global mean. And the average rating for that movie won't really matter. So the A is a damping factor, which means how smooth do we want it to be? Essentially, if we put A to a large number, it will require a lot of votes and high rating for that movie. But if we put A small, we'll really take into account the mean of that movie a lot. So we'll play around with this, but this is the formula we want to implement now. So if we were to, we're going to use pretty much the same thing as we did here, right? So we could do sum ratings, exact same thing, right? But we'll do a sum. So if we just look or sort of take a look at that, then we'll see like the sum ratings for that movie. And then, remember, we also have the number of ratings for that movie here as well. So let's go down. And so what we can do is, let's do it a sort of numerator and denominator. So we'll do damped numerator. It'll be the sum ratings, right? These are the sum ratings plus a damping factor times the global mean. Now, the global mean we haven't actually calculated, right? So if we do a global mean, it'll be, Copilot. We'll do a ratings data frame of rating, and then we'll, so this is it, yeah. So we don't group by anything, we just take the mean straight up. And then if we can print that. So 3.5 is the global mean for all movies. And now let's continue with the formula. So we have the numerator, right? If we looked at the denominator, then we want to have the number of ratings plus the damping factor. And remember here that, it's the sum of the ratings and the number of ratings. They're actually a data frame for all movies, right? So we're not calculating it for a single one here. We're doing it for every movie ID at the same time. So if we now do the damped mean rating, let's say, it will be the damped numerator divided by the damped denominator. And then we could do very similar thing as we did above here. Let's just copy paste this. So we put movies data frame of damped mean rating equals to the mapping of damped mean rating. All right, so let's just make sure that we're on, the code is a little bit messy. We'll clean it up in just a second. But here, if we now look at what we've done, right, we've calculated the global mean, so mu. We have the damped numerator, the sum of the ratings, plus the damping factor times the global mean. This is the numerator. Denominator, we have the number of ratings plus the damping factor, and then we just get the mean rating. We map them onto the movie data frame, and what we let's see what happened there. Okay, this is not a code block. Right. Okay, and so we need to set the damping factor as well. This is a hyperparameter that depends on really on the data set, and you can put, but normal value maybe it's like 5 to 20. So maybe I would set it to 10 as default. But really depends on the number of votes or ratings that you have for each item. So this is something that you can play around with a little bit on how much you want that trade-off to be. But in this case, I think 10 is going to be sort of a good number to start with. So let's again copy this sort values. So now here, right, we're taking the movies data frame, we're sorting it by damp mean rating instead, ascending false because we want the highest at the top. And then now we get, all right, so we have the mean rating, right? But we have number of ratings as well. So let us see what happens here. So this actually very nicely follows the mean rating. Yeah, but it does take into account, the number of ratings, right? Because previously, if we just ranked it by the mean rating, we won't get anything close to this, right? As we saw before. So maybe if we change this a little bit, then we can see here that we actually, this one, for example, it has a very low amount of votes. No, just 8 votes. But it has a very high mean rating. But that is still sort of lower in the ranking than these two because they have, more votes but a lower mean rating. So yeah, this is kind of coming to the point where you have to play around with this a little bit. I still think 10 might be a good one. Let us take with 10 of them. We can see. So here, for example, we can see that the mean rating here is lower than this one, but it's still higher in the ranking and so on. Yeah. So this is sort of the way that we do sort of a basic, simple recommender system, and you'll be surprised just how good this actually works in practice. Popularity is very strong baseline, and then you have to work very hard to beat it. So things don't have to be that complicated to start out with. If you are able to do popularity, then it's almost something that you want to start with, I would say. But let's also now let's clean this up a little bit. So we can do calculate popularity function, and let's take in the movies data frame, ratings data frame, and the damping factor. Let's set it to 10 as default. And let's just put all of these things here into this function. So after we've calculated all of these, let us, let's see, let us take all of this code here, right? So we'll take this mapping. And we'll put this inside there as well. All right, so what are we doing? We can remove the damping factor here because we put it in the function, right? So we calculate the global mean, and then we have the damp numerator. Cool. All right, and then at the end, right, we can return the movies data frame. So a recap, right? Let's go through it. We take the movies data frame, the ratings data frame, and a damping factor. We calculate the number of votes, number of ratings for each movie, the mean, and the sum. We also calculate a global mean across all ratings, and we saw this was 3.5. And then we calculate the damped mean according to this formula right here that we took a look at. And actually, let me move this a little bit as well. We can put this at the top here. All right, cool. And then we are sorting by num ratings, mean rating, and damped mean rating. And let's do also 5, so we can just see the difference for all of the 3 different ones. So always a good sanity check to sort of run it from top to bottom. And it didn't work. Right, we need to call this function. So movies data frame. Cool. All right, so we get sort of the same results as before. Yeah, I hope this was clear on popularity. This is you can apply this to many really kind of, now we had the ratings for other users. So this is really a solution to a cold start problem where you specifically the scenario where we are onboarding a new user, I would say, but this is applicable to many different scenarios where if you're able to find sort of what's popular in some way, then this is sort of the go-to, I would say. And you have, some ideas on how we can approach that now. In the future, we'll take a look at some, I haven't done this yet, but I'm thinking of taking a look at some Kaggle competitions and some actual projects. And so hopefully, at that point, we'll see this for another application as well. But I hope that this was useful, to get an understanding of how you would implement this in practice. And yeah, hope to see you in the next video.